Combinations. Example number 1. Consider a set with 4 elements A, B, C, and D. How many ways can you select 3 elements? By permutation, if order matters, we can list down 24 arrangements. We have ABC, ACB, BAC, BCA, CAB, CBA, ABD, ADB, BAD, BDA, DAB, DBA, ACD, ADC, CAD, CDA, DAC, DCA, BCD, BDC, CBD, CDB, DBC, and DCB. If we're going to use the formula in finding the permutation, we have the permutation of n objects taken r at a time is equal to n factorial over n minus r factorial. Since we have 4 elements, A, B, C, and D, and we need to take 3 at a time, so we have n is equal to 4 and r is equal to 3. By substitution, we have n factorial over 4 minus 3 factorial. Again, our 4 is n and our r is equal to 3. Simplifying this, our 4 factorial will be equal to 4 times 3 times 2 times 1. And 4 minus 3 is equal to 1, taking 1 factorial, that is equal to 1. So we have 4 times 3 is 12, times 2 is 24, times 1 is still equal to 24 ways. Going back with the listed arrangements, if the order of letters does not matter or important here, we can observe that ABC, ACB, BAC, BCA, CAB, and CBA have the same elements A, B, and C. Since the order does not matter, this will be considered as one arrangement. In the same manner, ABD, ADB, BAD, BDA, DAB, DBA have also the same elements A, B, and D. The same way with the next 2 sets of arrangements. So using combination, if order does not matter, we only form 4 selections. Combination is the number of ways of selecting from a set when the order is not important. Let's have example number 2. Given the 3 situations, let's identify which is or are situations considered as combination or combinations. First, we have there are 9 applicants for 3 computer programmer positions. Second, top 3 winners out of 7 contestants in Math Quiz B. And lastly, 10 badminton players chosen from a group of 12. The first situation, there are 9 applicants for 3 computer programmer positions. We need to select only 3 applicants from 9 applicants to be selected for the computer programmer positions. Since we have the same positions, there is no order needed in this given situation. So this is a combination. Likewise, 10 badminton players chosen from a group of 12. So we only need to select 10 players out of 12 to play the badminton. So since we have the same players, the same position, there is no order needed. This is also a combination. On the other hand, top 3 winners out of 7 contestants in Math Quiz B is not a combination. Since we need to take top 3 winners out of 7 contestants, there will be first place, second place, and third place. They are different winners, so they will be considered as different positions. And this requires an order. So this is a permutation. To solve for combination of n objects taken r at a time, we will use the formula n factorial over r factorial times n minus r factorial. Example number 3. In how many ways can a committee of 5 be selected from a class of 8 students? Our n is 8 and our r is 5. Using the formula n factorial over r factorial times n minus r factorial, we simply substitute the values of n and r. So again, n is equal to 8 and r will be equal to 5. So we have 8 factorial over 5 factorial times 8 minus 5 factorial. Or it would be 8 factorial over 5 factorial times 8 minus 5 is 3 factorial. Simplifying this expression, we'll have 56 ways. Example number 4. A class is made up of 15 boys and 20 girls. In how many ways can a social action group is to be made up of 3 boys and 4 girls? So we have to add 15 and 20 to have a total of 35 students. And then if we have to add 3 and 4 girls, 3 boys and 4 girls rather, we have 7 students. So first, we need to take the combination of the boys. So again, the total number of boys will be 15, and the boys, we need to take 3. So we have a combination of 15 objects taken 3 at a time. Using the formula again, we substitute. We'll have 15 factorial over 3 factorial times 15 minus 3 factorial. Simplifying this expression, we'll get 455 ways. And for our girls, our n is 20 and we need to take only 4 girls. We use again the same formula, and by substitution, we'll have 20 factorial over 4 factorial times 20 minus 4 factorial. Simplifying this expression, we'll get 4,845 ways. But since we have different groups, we have boys and girls, we need to multiply the results. Thus, we have 455 times 4,845 is now equal to 2,204,475 ways. Example number 5. In how many ways can a committee of 6 be chosen from 6 administrators and 4 supervisors if? So we have different conditions. So again, we have to select 6 out of 6 plus 4. So we have a total of 10. So first condition, all are equally competent. So we disregard if they are administrators or supervisors. So again, your n will be equal to 10 and we need to select 6. So we have the combination of 10 objects taken 6 at a time. That would be equal to 10 factorial over 6 factorial times 10 minus 6 factorial. Simplifying this expression, we'll get 210 ways. Next condition, the committee must include 3 administrators and 3 supervisors. So since we have different groups, we have 4 administrators and 4 supervisors, we need to multiply. So we have the combination of 6 administrators, taken 3 at a time, times the combination of 4 supervisors, taken 3 at a time. The total number of administrators will be 6, and for the supervisors, we'll have 4. Simplifying this, so again, we have 6 factorial over 3 factorial times 6 minus 3 factorial. And this will be equal to 20 ways if we select 3 administrators out of 6. And for the supervisors, we have 4 factorial over 3 factorial times 4 minus 3 factorial. Simplifying this expression, this is equal to 4 ways. And then, we need to multiply the 2 given results. So, 20 times 4 is equal to 80 ways. Example number 6. A math club is made up of 8 boys and 6 girls. So we have a total of 14. A committee of 7 has to be formed for the documentation of the World Teachers' Day program. In how many ways this can be done if the committee consists of? So first, there will be 4 boys and 3 girls. So since there are 8 boys, and then we need to take 4, and we have 6 girls, we need to take 3. So we have to multiply the 2 given results. So first, we have 8 factorial over 4 factorial times 8 minus 4 factorial times 6 factorial over 3 factorial times 6 minus 3 factorial. Simplifying this expression, this will be equal to 70 times 20, and that is equal to 1,400 ways. Next condition, at least 5 girls. When we talk about at least, it means greater than or equal to. So it could be 5 and any number higher than 5. But since the total number of girls is only 6, it could be 5 or 6. So we have to take 5 girls out of 6 girls. And since we have 7 committee members, if we select 5 girls, there will be 2 boys. So we have times the combination of 8 boys taken 2 at a time, plus if we'll use 6 girls out of 6 multiplied by only 1 boy out of 8 boys. So again, if we need to select 5 girls, there are only 2 boys to be selected. But if we'll use 6 girls, there is only 1 boy to be selected. Because again, according to the problem, we have to select 7 committee members. And then why do we need to add? It's because we're talking about or. It means addition principle. So it's either we use 5 girls or 6 girls. Simplifying these expressions, we'll have 6 factorial over 5 factorial times 6 minus 5 factorial times 8 factorial over 2 factorial times 8 minus 2 factorial plus 6 factorial over 6 factorial times 6 minus 6 factorial times 8 factorial over 1 factorial times 8 minus 1 factorial. And this will be equal to 6 times 28 times 1 times 8. Or this is equal to 1,344 ways. Next condition is at most 2 girls. When we talk about at most, this is not more than the given number. So meaning we have 2 or any number less than 2. So it's either we selected 2 girls, 1 girl, or without girl. So since the total number of girls is 6, so either we have to select 2 girls out of 6 girls, or only 1 girl out of 6 girls, or we don't have to select girl out of 6 girls. So if we selected 2 girls, there will be 5 boys. So again, the committee is composed of 7 persons. So 2 plus 5 will be equal to 7. The same manner, if we select 1 girl, there will be 6 boys. And if we're not going to select any girl, so therefore there will be 7 total number of boys. And then again, we have to use plus because it's either we use 2 girls or 1 girl, or we don't have to select any girl. So that's why we need to add the combinations. So simplifying the expressions, we'll have 6 factorial over 2 factorial times 6 minus 2 factorial times 8 factorial over 5 factorial times 8 minus 5 factorial plus 6 factorial over 1 factorial times 6 minus 1 factorial times 8 factorial over 6 factorial times 8 minus 6 factorial plus 6 factorial over 0 factorial times 6 minus 0 factorial times 8 factorial over 7 factorial times 8 minus 7 factorial. Simplifying the expressions, we'll have 15 times 56 plus 6 times 28 plus 1 times 8. Or this will be equal to 1016 ways. Example number 7. For what value of n will the expression, the combination of n objects taken 2 at a time equals 21, be satisfied? So again, we have the given. The combination of n objects taken 2 at a time equals 21. We need to express or use the formula. That is why we have 21 is equal to n factorial over 2 factorial as the value of r times n minus 2 factorial. And then we need to express our n factorial as n times n minus 1 times n minus 2 factorial. So why do we need to stop with n minus 2 factorial? It's because the denominator has n minus 2 factorial. So we can now cancel the expressions. So as we cancel this, we'll have 21 equals n times n minus 1 over 2 factorial. And we all know that the 2 factorial is equal to 2. So we can have 2 times 21 is equal to n times n minus 1. 2 times 21 is equal to 42. And then we distribute our n with the binomial n minus 1. N times n is n squared, and n times negative 1 is equal to negative n. And then we need to form an equation, specifically a quadratic equation, by adding negative 42 both sides. So we'll have n squared minus n minus 42 is equal to 0. So there are different ways in finding the values of n, but let us use factoring method. So the factors of n squared minus n minus 42 are n plus 6 and n minus 7. Then finding the values of n, we need to use or find the value of n That would be n is equal to negative 6 and n is equal to positive 7. Since we are using or identifying the number of objects, we'll just use the positive value. So our n is equal to 7.